Hello friends, welcome to my channel. This is the second class of the first lesson of 9th standard, real numbers. We have earlier studied about some numbers, whole numbers, natural numbers, integers, fractions and rational numbers. What we have studied in rational numbers is here. Rational numbers are the numbers which are written in the form of p by q, where q is not equal to 0 and p and q are integers. Examples also we have noted down a few, and we have taken another example that the decimal expansion of the rational number is the terminating, and if it is not terminating then recurring. So these are the examples. 3.5 it is terminating. 0 is also a rational number because it can be written in the form of p by q, and here if we divide we get 0 itself. Here minus 5 by 1 is also a rational number. 1.333, and then there are 3 dots. That means this 3 continues infinitely. So this is a rational number. 4.17 bar. This 17 bar, this bar indicates that 17 is repeating infinite times. Now today let us see what are irrational numbers. Rational number and irrational number both are opposite of each other. Now by seeing the definition, first definition of rational number, we can directly say that irrational numbers are the numbers which cannot be written in the form of p by q. So which are the numbers which cannot be written in the form of p by q? The numbers which cannot be written in the form of p by q, with this condition where q is not equal to 0 and p and q are integers. Now friends, which are those numbers which cannot be written in the form of p by q? Let's see. Example, root 2. Okay, root 2 cannot be written in the form of p by q, where p and q are integers. Of course we can write this root 2 as 2 divided by 1. Okay, root 2 by 1. But here you can see this root 2 is not an integer. Therefore, this will not be a rational number. This is an irrational number. Similarly, we can take root 3. Okay, can we take root 4 here? Root 4 we cannot take because root 4 is equal to 2, and 2 is a rational number which can be written in the form of p by q, where 2 is integer. So we can continue with root 5, root 7, root 10, root 50 and many more. This is according to the first definition, that the numbers which cannot be written in the form of p by q, we say that they are irrational numbers. We can define in one more way in terms of decimal expansion. Now here rational numbers we have decimal expansion terminating, and if it is non-terminating then non-recurring. For these numbers itself we have to find the decimal expansion and see what will be the definition of irrational numbers. Now children, you people are aware of dividing a number, finding the square root of the number using the long division method. Now let us take root 2. Okay, we will be finding root 2 value here, root 2 with the long division method, and we know the rules. 2 is only one number, so we will give a decimal after 2 and take a pair of zeros after that decimal to divide it. Okay, let's start with the perfect square number. Below 2 is 1, so 1 ones are 1, and subtracting this there will be 1 remaining, and we can take a pair of zeros down, and taking this 1 plus 1 we add it, it becomes 2. So we have to select a number here, same number we should be taking here. And also we should keep in mind that the decimal number is over here, so the integral after the integral plus put a decimal point after 1. So here we will be taking 24 4s are 96, and here we have remainder 4. Let us take another pair of zeros and continue the division. 24, this 4 should be added here again. So it becomes 28, and we have to take a number here. Ones are 1, 281, and when we subtract, the remainder will be 119. If we take another pair of zeros below and we add 1 here, it becomes 282, and the number we should select here, we have to do trial and error for this. 28244 are, we will be getting 11296. So if we continue, children, we will never get a 0 here. Remainder, we will never get 0 as remainder. Okay, and the decimal expansion continues like this, and approximately we'll get 4142136, and it continues infinitely. Now you can see here there is no particular block of digits which is repeating, and it is never ending process. So for irrational numbers we can write the decimal expansion of irrational number is non-terminating and non-recurring. The rational numbers are the numbers whose decimal expansion is non-terminating and non-recurring. There are infinite numbers like this. You can write any numbers. Say 4.0100100100001 and so on. So there will be no particular block of digits which are repeating 9.857982 and continue it like this. So these are the irrational numbers.